Okay, welcome back. So in this video we're going to look at using Gaussian elimination to solve a system of equations. So how you do this is you start by setting up your matrix. So you take all your coefficients that are in the matrix and you throw them, in your system and put them in a matrix. They're not already in a matrix. And then your last column here, you do put in the answers. Okay. You can kind of think of that being its own column, right? These ones are all the coefficients on x, y, and z, and then these are the numbers on the other side. Okay. So to solve this, we want to get this part to look like the identity matrix, or at least be in reduced row echelon form, meaning that there's leading ones in the rows and that there's zeros below them and zeros above those leading ones. And so what we're going to do here is we are going to get this to look like the identity matrix. And so Gaussian elimination, what you want to do is, your first step with that is you want to get that to be a 1, okay? Now you could divide that by -2 to get it to be a 1, but if you notice there's already 1s down below it, so I'm just going to switch rows so that maybe the second one is on top so that I have a 1 up top. So I'm going to switch row 1 and row 2. Okay, we're just going to switch those two. Okay, so what do we got here? 1, -2, 1, 3, and then -2, 5, -4, -4, and then 1, -5, 9, -5. Okay, there we go. So we switched those rows, so now I have a 1 in this position. Now if you remember, your next step with Gaussian elimination is you want to get rid of these, okay? You want those two to be 0, okay? So you're going to use this 1 to get rid of those two, okay? So to get rid of the -2, I'm going to do +2, because we need a +2 to cancel out that -2, times your first row, and I'm going to add that down to my second row. Okay. I'm also going to get rid of this 1 at the same time, so I'm going to do -1 times this row and then add it down. Okay. So I'm going to get those to be 0 down below it. Okay, so that first row isn't changing. Okay, but the second row is, right? We took 2 times the top row and then added it down to the bottom. So 2 times 1 is 2, plus -2 is 0. 2 times -2 is -4, plus 5 is 1. 2 times 1 is 2, plus -4 is -2. 2 times 3 is 6, plus -4 is 2. Okay. Now we'll do negative row 1 plus row 3. So -1 plus 1 is 0. -2 is +2, plus -5 is -3. -1 plus 9 is 8. And -3 plus -5 is -8. Okay. So there is our matrix where we have 1 leading 1 and then zeros below it. Okay. So our next step is we want to get a 1 right here. Okay. And notice there already is a 1 there. If there wasn't, I could either switch these two to get a 1 or divide by a number to get a 1 there. Okay, but in this case it's nice, I've already got a 1. So we don't have to do anything there. Then once we have that 1 there, we want to get zeros below it. So we want a 0 right there. Okay. So you're going to use your second row, the second row, to cancel out that 3. So you're going to do 3, row 2, and then add it down to row 3. That should cancel out that 3. Okay? So we get 1, 0, 0, and then 1, 0, okay, those aren't changing. Okay, whoa. That was fun. Okay, there we go. Okay. So 3 times 1 was 3 plus -3 was 0, right? 3 times -2 is -6 plus 8 is 2. 3 times 2 is 6 plus -8 is -2. Okay? This is going pretty well. Okay, so now what I'm going to do is I want this to be a 1, so I'm going to divide that whole row by 2. Okay, so this guy we want to be a 1, so we do 1/2 row 3. Just times that whole baby by 1/2. So we just times that by 1/2 all the way through. When I get that, I did get 1 and then -1. Okay. And now we are getting really close. This is what would be the row echelon form. And so this would be what's considered Gaussian elimination. You would stop here and then convert them back to equations and like back substitute in order to get it. But I don't know, I personally prefer doing Gauss-Jordan elimination, which is fine for this problem too. You can use either Gaussian elimination or Gauss-Jordan elimination. I usually like doing it that way. So that just means that I want to get zeros above my leading ones as well. Okay? So I'm going to get rid of this for a second so that we can get some more space. Okay? And what I'm going to do is you kind of work backwards from what you did before. On this, before we had kind of worked over this way, getting 1s and 0s below them. And so on this other part, we kind of go backwards. We start over here and get 0s above this 1 here, so right there. And then once we get them there, then we'll move on to that guy. Okay? So, what are we going to do? To get rid of that -2, we're going to need to do, we're going to use this row to go up to that one so that I don't mess up anything I've already done. I'm going to do 3 times the third row and add it up, or sorry, 2. 2 times the third row and then add it up to the second row. Okay. I'm also, to get rid of that 1 using this one, I'm going to do negative row 3, and I'm going to add that up to the first row. Okay. So I get okay, so 1 times 2 plus -2 is 0 there. And then -1 times 2 is -2 plus 2 is 0. And then negative 1 plus 1 is 0, and that's still negative 2 there because we've got a 0 here. So 0 times 2 is 0, plus negative 2 is negative 2. Okay, and then negative 1 times negative 1 is positive 1, plus 1 up there is 4. Okay, so we're getting really close. So now I just use this 1 here to get rid of the number above it. So I'm going to do 2 times row 2, and we're going to add it up to row 1. So we get well, 2 times this added up there will be 0, right? 2 times this is 0, plus 0 is 0. 2 times 0 is 0, plus 4 is 4. Okay, so what does this mean? This means that if I wrote these back as equations, this would be 1 times x equals 4, 1 times y is equal to 0, and then 1 times z is equal to negative 1. And so my answer here is 4, 0, negative 1. Okay? So hopefully that helps with that question. Kind of remember some Gaussian elimination. I think this is fun. I really enjoy this process. So anyway, hopefully you will too, and I will see you guys in the next video.